All right, 10, 11, and 12, we are doing limits at infinity again. So as x approaches infinity, we want to find the limit. So they've got a few rules for us to follow if I have a rational function. In other words, I have a fraction. So, if the degree of the top, is less than of the bottom, degree of the top is less than the degree of the bottom, then the limit equals 0. If the degree of the top equals the bottom, the degree of the top is equal to the degree of the bottom, then you're going to have the ratio of the leading coefficients. We'll get to that. And if the degree of the top is greater than the degree of the bottom, that's our third case, then I'm going to either have positive infinity or negative infinity for my limit. And I have to figure out which one it's going to be. So, those are my rules as x approaches infinity if I have a rational function, which is a fraction. So here, the degree of the top is 1. The degree of the bottom is 2. 1 is less than 2. So the degree of the top is less than the degree of the bottom. Well, that makes it really easy. The limit as x approaches infinity is just going to be 0. Hey, I'm done. That was an easy one to do. Wish they all were that way. If we look at part B, the degree of the top is 3. The degree of the bottom is 2. So the degree of the top is greater than the degree of the bottom. By the way, they're assuming you remember how to find the degree of your polynomial. The degree is the degree of the highest term. So a constant term has a degree of 0. This has a degree of 1. So it's a linear 1. It's a degree of 1. Here my highest exponent is a 2. So it has a degree of 2. So here my highest exponent is 3. Here it's a 2. 3 is greater than 2. So it tells me the degree of the top is greater than the degree of the bottom. So I know my answer is either going to be positive infinity or negative infinity. So what I need to do is figure out the sign of my answer as I approach, in this case, negative infinity. Now, if I'm going to approach negative infinity, I want a big negative number. I'm just going to say I'm going to use negative 1,000. That's probably big enough. You probably don't want to use negative 1 or negative 2. It's kind of small, but we're going to use negative 1,000. I'm going to plug that in to see if I'm going to get a positive answer or a negative answer, which tells me if I'm going to go to positive infinity or negative infinity. So negative 7 minus 4 times negative 1,000 cubed over negative 7 minus 2 times negative 1,000 squared. Now, I'm just worried about the sign. I'm really not even worried about my numbers. So if I take negative 1,000 and I cube it, that's going to stay negative. Nope, I better work it out, because otherwise I have to figure out my number. I'm just going to use my calculator. So on the top, I was going to take a shortcut, but that's not going to work very well. So I'm just going to punch the top in. Negative 7 minus 4 parentheses, negative 1,000, 1, 2, 3, cubed. Gives me 3,999,999,993. It's a positive number. On the bottom, negative 7 minus 2 parentheses, negative 1,000 squared. Gives me negative 2,000,007. Now, I have a positive over a negative, and since I have a positive over a negative, I'm going to get a negative. And in this case then, since I know that it's going to approach infinity, I'm going to say, okay, I'm approaching negative infinity. So you really don't care what the number answer is. You're just checking to see what the sign of the answer is. Is it going to approach a negative number or a positive number? You can see I'm going to have a really big negative number, so I'm going to approach negative infinity. All right, so if I look at the next one, I'm finding the limit as x approaches negative infinity. The degree of the top is 1. The degree of the bottom is also 1. So the degree of the top equals the degree of the bottom. So that means it's going to be the ratio of the leading coefficients. The leading coefficients are the coefficients of the number in front of your highest exponent term. So in this case, this would be my leading coefficient of 7. This would be the leading coefficient, the negative 5. And so I'm just going to have negative 7/5 for my limit. If I put that in best form, I'd have 7x plus 1, negative 5x minus 6. There's my leading coefficients. They're both out in front of my expression. So if the degree of the top is the same as the degree of the bottom, my limit is going to be the ratio of their leading coefficients. This one, the degree of the top is 3, the degree of the bottom is 2. There's one of those that I have to check. 3 is greater than 2. So I know my limit is going to be either positive infinity or negative infinity. I'm checking as x approaches positive infinity. So again, I'm going to use 1,000. I'm going to use a positive number. On the previous one, we were doing negative infinity, so I use negative 1,000. So I'm going to take 5 times 1,000 cubed plus 1, and then negative 6 minus 7 times 1,000 squared. So 5 times 1,000 to the third plus 1 gives me 5,000,000,000,001. On the bottom, negative 6 minus 7 times 1,000 squared gives me negative 7,000,006. So again, I have a positive over a negative. A positive over a negative is a negative, and so it's going to approach negative infinity. My number is just going to get smaller and smaller and smaller and smaller. The bigger the number I use, the smaller my answer would get, the more negative it would be. Number 12, I'm checking my limit as x approaches negative infinity. This time the degree of the top is 2, the degree of the bottom is 1. So the degree of the top is greater than the degree of the bottom. So if the degree of the top is greater than the degree of the bottom, again, this is one I have to check. I'm approaching negative infinity, so I'm going to use negative 1,000 again. So if it's negative, I use a negative number. If it was positive, I'd use a positive number. And you want to use a fairly big number. So I picked 1,000. So I'm going to do 2 times negative 1,000 squared plus 3, and 4 times negative 1,000 minus 3. So 2 times negative 1,000 squared plus 3 gives me 2,000,003. It's a positive number. On the bottom, 4 times negative 1,000 minus 3. It's a negative number, 4,003. A positive divided by a negative is a negative, and so I know that it's going to approach negative infinity as x approaches negative infinity. My graph is also going to approach negative infinity. And the last one here, the degree of the top is 2, the degree of the bottom is 3, the degree of the top is less than the degree of the bottom. If the degree of the top is less than the degree of the bottom, the limit is just 0. So again, if my top is less than my bottom for the degree, my limit equals 0. If the top equals the bottom, you have the ratio of the leading coefficients. And if the top is greater than the bottom, either going to get negative infinity or positive infinity, and you're just going to substitute in a really big number or a really small number and check to see what is the sign of your answer. That's going to tell you if you're at a positive infinity or a negative infinity.